This is a TReX training video on how to use the inbuilt spectrum analyzer. Spectrum analyzer can be used to examine potential site interference and determine the quality of an installation. In order to use spectrum analyzer, we go into the menu, go to the spectrum analyzer screen. Here we can configure various items to display signals as well as possible. Here we can set the center frequency, and that can be within the VHF or UHF band. Here we can configure the span on the 250 kHz per division setting. We can have a span of up to 3 meg, and our other settings allow, in this case, a span of 120 kHz, and this one is a span of 24 kHz, since there are 12 divisions across the screen. The most useful setting generally is the 120 kHz setting there. We can change our sample method, whether it's continuously updated or a peak value is obtained, and we have the ability to scale and offset the signal to display that signal as well as possible on the screen. Using these settings, have a look, and we can see in this case that across the span of 3 meg we have a strong signal in the center, and that is a signal that has been generated here from a test set, and we can see that the noise floor is sitting somewhere around minus 110 dBm. When we change our span, you can find out more about the nature of that signal. And here we can see that we have modulation lobes to each side, and that is because we have a signal that is deviating at 4 kHz. If we were to increase that, we'll increase that now to 10 kHz. And it is 10 kHz now. You can see that it sits one division out on each side, which correlates to the setting of 10 kHz per division. In this case, we can see that there is, from the test set, quite a wide power distribution, and that's because the test signal is a square wave. We will change this. The sine wave, you can see that the power that has gone into the adjacent channel has reduced. As an example, now we'll change the frequency to frequency that is used here for the nationwide paging network. So there are two signals that are operating on two different frequencies here, but because the span is quite wide, well, the span here in this case is set to 120 kHz. We should see two signals that come and go, one to the left of the center and one around the center. It might be useful to capture that signal, and so this case, we'll change our sample to peak. And over time, we'll have a better picture of the activity across that span. And there will be another frequency, another signal that appears to the left, most likely at some stage soon. And we can see that the approximate nature of the signal, in this case, peak to peak, we have approximately one division between the lobes, side lobes, and so that we know the deviation is approximately plus or minus 5 kilohertz. To clear the screen, press the square button and it will refresh again. That's a good summary of how the spectrum analyzer works. Thank you.